The amygdala is the brain's central alarm system, detecting threat signals faster than conscious reasoning. When a myth is emotionally charged, the amygdala fires first, tagging the information with salience that primes memory and attention. These fear-driven signals propagate through the hippocampus to anchor context and through the prefrontal cortex for evaluation. But the amygdala dominates early processing. What we perceive as belief is often first encoded as emotional urgency, not as rational appraisal. This explains why myths tied to fear persist. The brain's circuitry prioritizes survival over truth, locking these narratives into attention, memory, and decision-making pathways before any conscious questioning occurs. Fear-laden experiences are inherently sticky because the amygdala amplifies hippocampal consolidation. Each repeated exposure to a myth triggers dopaminergic and noradrenergic feedback that strengthens synaptic connections, embedding the belief deep in memory. Importantly, these memories are emotionally tagged, making the subjective experience of truth feel undeniable. Even when confronted with empirical evidence, the emotional memory can override rational processing. In essence, myths persist because the brain encodes them as emotionally significant survival information, creating a neurochemical bias toward maintaining outdated or inaccurate beliefs. Belief persistence is not a failure of intellect. It is the architecture of the emotional brain. The amygdala and hippocampus form a network where fear signals enhance synaptic connectivity, while top-down regulation from the prefrontal cortex struggles to override entrenched emotional circuits. Neural firing in this system prioritizes meaning and relevance over fact, ensuring that emotionally threatening myths are consolidated and defended. This structural asymmetry explains why intelligent individuals often cling to myths. They are not irrational. They are neurobiologically optimized to protect the system from perceived threats, even if the threat exists only in narrative form. The persistence of myth is reinforced by the interplay between fear circuits and the dopaminergic reward system. Each confirmation of a fear-based belief triggers dopamine release, which the brain interprets as a reward, strengthening synaptic pathways that encode the belief. Here, emotion and reward converge. Fear motivates attention. Dopamine motivates retention. The result is a self-reinforcing belief loop, where myth-consistent experiences feel gratifying despite being objectively false. Understanding this mechanism allows us to see belief not as knowledge, but as a structurally reinforced network that requires deliberate, multi-layered intervention to reconfigure.
Mature fear-driven beliefs form distributed networks in the brain, interconnecting the amygdala, hippocampus, prefrontal cortex, and associated reward circuits. When a myth challenges these networks, the brain interprets it as a threat, activating defensive emotional circuits that suppress analytical reasoning. Top-down executive control attempts to inhibit the fear response, but the network's redundancy and emotional reinforcement make correction extremely difficult. This network-level architecture explains why myths persist across generations and why single facts rarely suffice. True belief revision requires strategic neural reconfiguration, engaging attention, emotion, and reward simultaneously to rewire entrenched circuits.